Okay, it looks like it's just about time to get started. We're going to be talking right now about analyzing the graph of a function. And we're going to talk, to start with, about even and odd symmetry. Now, symmetry is a concept that's pretty easy to understand. It's a little bit like sort of folding things up and things should overlap. So we've got two different types of symmetry. We've got even symmetry and odd symmetry. And we talk about something that's symmetric with respect to, we've got two different types of symmetry here, and we'll talk first about this even symmetry. And even symmetry is what happens when I've got some function where I plug in a negative value or the opposite value for my x, and it equals the same thing as the value, my original value for f of x. Now, what does that mean? Well, let's talk about that. So, if we were to take a look at a graph, if I take any point here, any positive value for my x, let me use a different color here. If I were to take any positive value for my x, my apologies, I've got some traffic noise outside, I would have some value for my f of x. But if I were to go on the opposite side of the y-axis and go out that same distance, I would end up with that same height for that negative f of negative x. So we'd notice that I could literally fold this right along the y-axis, and I would end up with the same things. So any value I pick, like, let's take this as like f of x2, and right over here on the other side, f of negative x2. I would have the same for whatever x values I chose. I could basically fold this graph and meet up on the other side of the y-axis. So this is what we mean when we talk about even symmetry. Well, kind of begs the question, and I have it right up here, we've got odd symmetry as well. Well, what is odd symmetry? Odd symmetry happens when instead of having, if I plug in a negative value for my x, if I go out a certain distance, and I were to look on the opposite side of the y-axis, what happens is it doesn't just flip, it also flips over the x-axis. So we would find the opposite value in the y direction. So let's take a look at what that might look like. So here we can take any value in this x direction. Here's my x, and here would be my f of x. Well, if I were to go in the opposite direction here, negative x, I would notice that instead of being positive, at least in this case, I would end up with a negative value. It would be going down. This is my f of negative x is equal to negative f of x. So what happens is I find this sort of symmetry along a line of y equals x. But any place I go on here, if I were to go out to, say, this value here, I'll call this, this would be f of, say, x2, we would find, so this would be out here, this is, we'll call that x2, this would be negative x2. This value of f of negative x2 would be the same thing as the opposite sign of our f of x2. So now we've got a little bit of an idea of what we can do. So let's take a look at what might happen, how to determine if something is either even or odd. And one of the things that we can do with this is we can go ahead and plug in to any function a negative x and see if it matches up with our original, or how it matches up to our original function. So let's take something like, for example, f of x is equal to x squared plus 3. Now, to test this, we're going to plug in a negative x in. So what we're going to do for our test, we're going to plug into this function. We're going to see what our f of negative x looks like. In this case, I'm going to end up with negative x squared plus 3. Well, negative x times negative x is going to be the same thing as, well, negative times negative is positive, x times x is x squared. So this is going to be the same thing as x squared plus 3. And notice that this right here is the same as our original. Which tells us that this has got an even symmetry. I could also try this out with something else. Say we were to try this with another function. And let's just say we've got like x cubed, I'm going to go a little bit different this time. I'm going to go x cubed minus 2x. Once again, we're going to test this. And when we test this, we're going to plug in our negative x for our original value, for our original x. So here, we're going to see what happens. F of negative x is going to be the same thing as, well, it's going to be negative x cubed minus 2 times negative x. Well, negative x times negative x times negative x, that's going to be the same thing as negative x cubed. Minus 2 times negative x, that's a little bit like saying plus a 2x. Well, these two functions look the same, except that notice that all of our signs are reversed. So what I'm going to do now is I'm going to factor out a negative 1. And when I factor that out, both of these signs are going to change. It's going to be x cubed minus 2x. Okay, so our f of negative x, thinking about this, this is, you know, I can look at this and say this right here is our f of x. So this is going to be the same thing as negative f of x. This tells us that we have odd symmetry. Now, we've talked about even, we've talked about odd. There are cases where it is neither. And let's show you what this test will look like on something that is neither even or odd. So if we take some function, and I don't know whether or not it's even or odd symmetry, but I'll take some function here like f of x is equal to, I'm going to do x squared minus 6x. And let's test this. We're going to plug in a negative x and see what happens. So when I plug in to our function here, a negative x, this is going to give us negative x squared, and that negative x is inside parentheses, minus 6 times our negative x. Well, here, negative x times negative x is going to be positive x squared. Negative 6 times negative x is going to be the same thing as plus 6x. And this is different. It's got the same sign on this first term, but it's got an opposite sign on that second term. So I can't rewrite this as, I can see right off the bat, it's not going to have even symmetry because it doesn't have the same signs on these terms. It also doesn't have odd symmetry because both of my signs would be reversed, not just one of them. So this is neither even or odd. Oops. Alrighty. That's all we've got for right now, and I will catch you in the next video.